Chapter 6, the Gauss map. An orientation on an end surface S is a smooth unit normal vector field on S. And smooth unit normal vector field maps each point in S to a unit vector at that point. And suppose consider an oriented end surface S with the orientation n, where n of p equal to p n of p for each p belongs to S. Here, when we consider this vector n of p, this n of p, here norm of n of p equal to 1, and which is equal to norm of n of p equal to norm of n of p, and it is also equal to 1, which implies this n of p, this vector n of p in Rn plus 1 is a unit vector. And since the norm of n of p equal to 1, we can say that n of p belongs to the n sphere S in Rn plus 1. That is, if p belongs to the oriented end surface S, then n of p is a point in n sphere. That is, n, when we consider this n as a map, n is a function from the oriented end surface S to the unit n sphere Sn in Rn plus 1. That is Gauss map. Let S be a oriented end surface in Rn plus 1 with an orientation n of p equal to p n of p. Then the map n from S to Sn, where Sn is the set of all unit vectors in Rn plus 1, is called the Gauss map. And the set n of S equal to the set of all n of p such that p belongs to S is called the spherical image of the oriented end surface S. That is, image of S under the map, under the Gauss map, is called the spherical image of the oriented end surface S. For an example, consider the function f from R3 to R defined by f of x1, x2, x3 equal to x2 square plus x3 square. And consider the level set S equal to f inverse of 1, which is equal to the set of all x1, x2, x3 belongs to R3 such that x2 square plus x3 square equal to 1. Here f is a smooth function, del f of p is not equal to 0 for each p belongs to this level set. Hence, S is a two surface in R3 and it is orientable also. Consider the orientation n equal to del f by norm del f, where del f of p equal to p dou f by dou x1 of t, dou f by dou x2 of t, x2 of p, dou f by dou x3 of p. And if p equal to here dou f by dou x1 is equal to 0 and dou f by dou x2 equal to 2x2 and dou f by dou x3 equal to 2x3, and if P equal to P1, P2, P3, del F of P equal to P0 to P2 to P3. And norm del F is equal to root of 2P square, that is 4P2 P2 square, that is 4P2 square plus here the square of 2P3, that is 4P3 square, and it is equal to 2 into root of P2 square plus P3 square. Since P belongs to S, the P2 square here P belongs to S implies that P2 square plus P3 square equal to 1. Hence, it is equal to 2. So, the smooth unit normal vector field N maps P onto the point P0 to P2 to P3 by 2, and which is equal to P0, P2, P3. That is N of P equal to P0, P2, P3, and we here 0, P2, P3 is the associated function corresponding to this smooth unit normal vector field. So the Gauss map N is defined by N of P equal to 0, P2, P3. And here the spherical image of the oriented to surface S is, by definition, it is equal to N of S, and it is equal to the set of all points N of P such that P belongs to S. And if P equal to P1, P2, P3, then N of P is equal to 0, P2, P3, where P1, P2, P3 belongs to S, and which is equal to the set of all 0, P2, P3 such that here P1, P2, P3 belongs to S if and only if P2 square plus P3 square is equal to 1. So the set is equal to the set of all ordered triplet 0, P2, P3 such that P2 square plus P3 square equal to 1. And here we can see that this set N of S is not equal to the whole 2 sphere S2. So we can say that this Gauss map is not on 2.